What's up everyone, my name is Perfect, and today we are going to do basic trigonometry, solving right angle triangles. And I have a question with me here, but before we answer this question, I'm going to explain the formulas that are used to solve right angle triangles and how to identify the sides of right angle triangle. So I have a right angle triangle here. So you know it's a right angle triangle by a 90-degree angle here. So let me label it 90 degrees here, and here we have our theta. So this sign is called theta and it represents an angle. So a right angle triangle has three sides, namely the hypotenuse, the opposite, and the adjacent. So the hypotenuse is the slant height, or the side opposite 90 degrees. On our diagram here, the hypotenuse is AB. So this is our hypotenuse here, because it's opposite 90 degrees, which is hypotenuse is AB. And the opposite is the side opposite theta. So on our diagram here, our opposite is AC. AC is the opposite. And the adjacent is the side with two marked angles. So on our diagram here is CB. This is our adjacent. Adjacent is CB. And there are four formulas that are used when solving right angle triangles, which are the sine theta, cos theta, tan theta, and finally the Pythagoras theorem. And to define these formulas, there's an abbreviation that is usually used, which is the Chashotau. So for this C, it's adjacent of hypotenuse, and this S is sine theta, which is opposite of hypotenuse, and this T is for tan theta, it's opposite of adjacent. So our sine theta is from this abbreviation, which is opposite over hypotenuse, and the cos theta from our C here is adjacent of hypotenuse. And finally, the tan theta is opposite of adjacent, opposite over adjacent. And for the Pythagoras theorem is defined as hypotenuse squared is equals to opposite squared plus adjacent squared. So this is the formula for the Pythagoras theorem. So let us go back and answer our question here. So on our diagram here, we have a rectangle, namely ABCD, and AB is cos centimeters, which is equal to DC, and BC is 5 centimeters, which is equal to 80. And the first question is saying calculate tan ACD. And guys, whenever you see this sign, it means that our theta is at C. So let's label on our diagram at C here. Let us put our theta. So this is our sign for the theta, which is representing an angle. And here we have 90 degrees because it's a right angle, and on the corners of the right angle we have the 90 degrees. So the tan ACD, like I said from the previous page, that there's a abbreviation which is used, which is Chasho tau. And here we have to find tan, which is opposite of adjacent. So tan ACT is equals to opposite over adjacent. So our opposite here on our diagram, like I said before, the opposite is the side opposite Peter. So the side opposite our Peter here is this side, which is equal to BC. So BC is 5 centimeters, which means this side is 5 centimeters as well. So our opposite is 5 centimeters, and the adjacent, like I said, is a side with two marked angles. So our side with two marked angles is DC, which is 12 centimeters. So this is our answer. Tan ACD is equal to 5 over 12. And the second one is saying calculate cos DAC. Cos our triangle DAC. So like I said, whenever you see this symbol, it means our Peter is at A. As you can see here, previously our Peter was here at C, but now it moved to A. So we are going to put our Peter at A. So which means our sides are changing. They are changing totally. So our Peter is now at A. So cos, let me write down here, cos DAC. So our Peter is at A, which means now our adjacent is 5 centimeters and the opposite is 12 centimeters, and this is our hypotenuse. So from our abbreviation, cos is cos to adjacent of hypotenuse. Cos to adjacent over hypotenuse. So our adjacent here is the side with two marked angles, which is 5. And our hypotenuse, which is AC. We don't have the hypotenuse here, so we have to find it. So like I said, to find the missing sides on a right angle triangle, you use the Pythagoras theorem, which goes by the formula of hypotenuse squared is equals to opposite squared plus adjacent squared. So it's hypotenuse squared is equals to adjacent squared plus opposite squared. So here we have to find the hypotenuse, and our adjacent on our triangle ACD, our adjacent is 5 centimeters, and our opposite is 12 centimeters. So we say 5 to the power 2 is 25 plus 12 to the power 2 is 144. So 25 plus 144 is 169. And here we have the hypotenuse squared. So to get the hypotenuse, we root both sides. So here we are, so that we can be left with hypotenuse. So the root of 169 is 13. So we're going to substitute here with 13. So this is our answer for the cos DAC. And the final question is saying calculate the sine BDC, the sine triangle BDC. So we have to draw our triangle BDC to split it from the whole diagram. So for sine B D C, from our abbreviation, sine is equal to opposite over hypotenuse. Opposite over hypotenuse. So let us split this triangle BDC so that you can understand clearly. So this is our triangle here. Here we have B, and here we have G, and here we have C. So here we have 5 centimeters. Here we have found this hypotenuse is 13, and this is 12 centimeters. So for sine BDC, it's opposite of hypotenuse. So on our diagram here, we are going to put our theta at D. So let's put our theta at D here. So our opposite now is the side opposite theta, so it's 5 centimeters. Our opposite is 5 centimeters, and our hypotenuse is the slant height or the side opposite 90 degree, because here we have 90 degree angle is 13. So that's how you solve right angle triangles. Thank you guys for watching. Don't forget to subscribe to the channel and turn on the notification button so that you get notified every time I upload a new video. And I also recommend you to watch the other video that I put a link in the description. It's the video for how to solve non-right angle triangles. See you in the next one.